So, hello everyone again. I'm very glad to be here. My name is Omar Rahal, and today I will be presenting for you my past and present research titled Outdoor Measurements of Airborne Pollutants and the Dispersion in Presence of Green Trees. So, as an outline, it will be consisting of an introduction, a brief introduction, a literature review with an experimental background, my objectives for the experiment, my methodology, some results, and a conclusion with discussion. So, air pollution has been a pressing issue for decades, especially in urban environments. The World Health Organization estimated around 4.2 million premature deaths globally linked to ambient air pollution. This was in the year 2019, by the way. And complications included many diseases like heart, stroke, pulmonary disease, lung cancer, and infections for children. So my research was based on many previous ones. For example, the first picture on the left is for a previous research in 2021 showing a smoke detection model where they used a model to check for smoke and non-smoke pictures in order to identify the smoke. The second picture shows instead sand beds, which are solid fine particles that were dispersed in a wind tunnel environment, and they used a sand collector to measure their concentration. While the last one is a building model inside a wind tunnel at a scale 1 to 100 with real life scenarios. They had multiple buildings as we see, and one of the buildings had a tracer gas in it in order to show airflow and pollutant exchange. So this is my first part of the literature review, is about the generation of smoke and the flow with particles, either gaseous or fine solid ones. My second part was the ways were used to mitigate this emission or reduce the concentration of these pollutants. So first, I seen many old experiments or previous experiments like the one above, the one on the left, the Gromco, 2011, they had a model suggesting that avenue trees can be effective in pollutant dispersion and capturing pollutants in neighborhoods. They used a wind tunnel and they had good results as well. While the picture in the middle is for a previous study done by Lee in 2013, where it shows the effectiveness of trees in absorbing carbon dioxide emissions. And impressively, they reached 43% of reduction. But this impact changed from positive to negative as traffic density increases, which is very interesting. For the last one, a wind tunnel study was done to show the effect of cypress trees in reducing fine particulate matter around buildings. And they showed a 20% of reduction. And just to know that fine particular matter are very dangerous, and they can go inside our lungs, and the body can do nothing about it. So reducing them from the environment is very helpful. As for my experiment, the objective was to use a smoke source that generated smoke in a airflow, and then we need to measure the carbon dioxide emissions from this smoke and try to reduce it by using green trees. This figure here gives just a graphical summary of what I've been doing. So basically, we have to check the airflow behavior and the velocity profiling with and without the presence of trees. To do this experiment, I had several parameters where I varied them. For example, the number of smoke pellets used. So the more smoke pellets, the more smoke is generated. The tree types, which I have three tree types, and all of them with different dimensions, heights and width and density and porosity as well. The height of the smoke pellet, because we need to check how can smoke actually reach our sensor, just to validate the effectiveness of our sensor, the smoke sensor height as well, and dimensional parameters like the distance between the obstacle and the smoke and the target. And by the target here, we mean like pedestrians or buildings or neighborhoods. So anywhere that we can protect from these emissions. As a first step, we had to validate a velocity profile, because in real time scenarios, velocity profile is usually developed. And this figure on the left shows us the different categories of velocity profiles, while the one on the right is my calculation, where it basically is closest to the open terrain profile, the one in green, as we see here. To measure this velocity profile, I used a Testo 405 hot wire probe anemometer, and I tested it using many positions inside and outside the wind tunnel. So my wind tunnel was like it's shown here as a diagram. I positioned my anemometer as shown inside, and then outside. The velocity profile was developing in each step until it was well developed outside the wind tunnel at a distance of 50 centimeters away from the outlet. Of course, a fan here was used to generate airflow, and the grid that you see in the beginning is just to uniform our airflow. This is a picture from my experiment, or one of the many pictures actually. So the first one is a wind tunnel that shows a grid and a fan at the back. It's not shown clearly because the grid is just there. And the ones on the right are a different configuration of trees. So here I used three types of trees in many configurations, and I placed them between my smoke source and the smoke sensor to see how can they effectively reduce carbon dioxide emissions. This diagram here just shows you some configurations I used in my experiment. So if we take the first one, for example, the one that says V_3A, V is the direction I placed my trees. So V means vertically, so that's parallel to the flow direction. And 3A means 3 trees of type A were used. So they follow as V3B and V3C, whatever, until we reach the last one, which is H9CBA, where I used all 3 trees in a horizontal way. And horizontally, I mean it is perpendicular to the flow direction. More than 550 experimental scenarios were investigated. And on the left, you can see the types of trees that I used. They are very tiny, by the way. So the highest one is 11 centimeters and the lowest is 6. This figure here shows when I used 3 different types of trees, how carbon dioxide concentrations were reduced. So for tree type A and tree type B, both of them almost reduced 9% of the carbon dioxide emitted, while tree type C, a little bit less, around 7%, because of its low porosity. Uh, uh, Before doing all this, of course, we tested our sensor at a distance, which we called LB. There was no presence of trees, and the carbon dioxide concentration was observed. It was noted that when LB was less than or equal to 50 centimeters, there was no reduction in carbon dioxide. So we had to place our target away by 70 centimeters and above. So this bar graph here shows at a distance of 70, 110, and 150 centimeters away from the outlet. The light blue one is without any presence of trees, and the others are with the presence of different configurations of trees. Let me tell you that we almost reached 42% of reduction in our best case scenario. And among these configurations, the V6AB was the best configuration. Of course, I didn't have space to show all the experimental scenarios. As a conclusion, this research investigated the potential of using natural solutions, mainly to protect sensitive urban zones from direct exposure to large airborne pollutant concentrations. And by using a different combination of trees, we can actually reduce this concentration by at least 20% and up. And now for my future work, I will be conducting PIV measurements in a lab, and will need to measure local flow velocity fields and maybe use different types of particles, not just carbon dioxide, but also fine solid particles in the presence and absence of trees and their canopies. This is just a reference slide that shows the references if you're interested in the topic. And thank you all for your attention. I'm happy to answer all your questions.